Welcome back to the last session for today. Our next presenter is Mark Graves. He will be talking about Python-powered RESTful API basics with Web2py.
All right. Hey, thank you all for coming. Do we want the lights down for this, or it doesn't matter to me? I don't know if that's, and no, that was how it was before. So, can you guys see the screen? Okay. Cool. Alrighty. So this is what's that? All right. So this is Python-powered RESTful API basics with Web2py, and I am Mark Graves. So let's first talk about some goals. So the goals for this talk are to define some terms primarily first. Hypermedia API REST, resource collection RESTful API. Then we're going to go over basically the RESTful design, the RESTful API thought process. So what is this whole REST thing? What is an API? Why do we use it? And then, you know, how do we actually come up with that given we have kind of a circumstance? And then why do we use Web2py, or why do I use Web2py, and how do I use Web2py in order to make that very rapid process? So to start out with, let's talk about Hypermedia. So Hypermedia is a non-linear medium of information, including basically all of, you know, the different multimedia elements, but it's not just the text. So Hypermedia is an extension of the term hypertext, hypertext markup language you're probably all familiar with, HTML. Hypermedia is just the notion that you have a whole, you know, you have your hypertext document, and, you know, you can represent resources as links and entities within there. So images, media files, the text, the links, the relationships between them. So if you see the term, or if we talk about the term hypermedia, that's what we're talking about. So what is an API? An API is an application program interface. The way that I think about this is it is a contract. It is a contract between two applications. One is the application, one is the program. And the general format of that contract is given when then statement. So given I'm a server, when I receive instruction X, then I'm going to either perform an action or retrieve some data. And so why do we actually create APIs? What is the purpose? Does anybody want to, you know, wager a guess? And there's a lot of right answers for this. There is no real right answer, but there's a lot of reasons. Anybody want to wager? So that's one distinct use case, definitely. So what we'll talk about here is in terms of REST. So this is going more into REST, but I want to touch on the second point there. So describing a uniform interface between client and server. So as you start building out a web application, typically, or, you know, in my experience, you have somebody, they approach you, they say, these are my needs, and they build it up, and they have their initial product, and that's working, and then they figure out that actually it has to be tweaked just a little bit. And so, you know, then they decide, well, we'd actually like a mobile app. Well, we don't just want an iOS app, we actually want an Android app too. Actually want an Android app and an iOS app and a web app, and we'd like a desktop app, and we'd like them all to sync. Okay, well that's, you know, it's a substantial level more complexity, and so defining the communication protocol between those two is really useful. So for that, the style that I attempt to go to, and I will be, you know, very upfront and say this is, you know, not easy nor am I perfect at it, is REST. So what does REST stand for? REST stands for Representational State Transfer. And, you know, we said protocol earlier, so there's a lot of protocols for APIs. You can use, you know, a lot of different methods of interaction. You can use XML, SOAP, WSDL, but the difference between REST and some of those other things is REST is actually not a protocol, but a style. And that's important. So a protocol is very specific, and it has very specific limitations and very specific guidelines that you have to fit into. So it's easy to understand if you're following, because you can validate it. But the problem that you get is the flexibility of implementation. And so REST is kind of the opposite of that. REST is not a protocol, so it doesn't have the specifics, But in that, in that same vein, then what you lose by gaining the flexibility is that standardization. Now, there have been a number of different attempts to kind of standardize that process, and two of the biggest ones that I would say are the Open API initiative, and then RAML, so RESTful API markup language. Both of these tools I have found lacking, quite frankly. And that's not anything bad against the developers. They're doing amazing things, but it's been difficult to implement a standard on something that, doesn't have a standard. And so you find, I could pull up a GitHub issue session, and there's probably 300 comments going back and forth about, well, why doesn't it deal with inheritance and polymorphism in this particular way? And they have one particular way you want to do it, and that means that you have to work around it in your application, so that can be troublesome. So what this is all to say is REST is an architectural style, not a protocol. It's not the one solution. There is no one solution, but it can be useful. So what does REST do? REST decouples the representation, so the first word there is representation, of a resource from the actual underlying data. So what that means is you're agreeing to a contract that whenever I want to interact with an object on my system, this is the format that I'm expecting to get. And one of the other portions of REST is actually that it is stateless. So you have to actually assume that whatever information that you're getting is all the information that you need to interact with that resource. So that is an architectural style thing, but it just means that basically if I send you a packet of information, a packet being a JSON blob, or you could have a RESTful API over XML, basically whatever information you get, this is the format that I'm getting it, and I can send it back, and I have everything that I need in my one little packet in order to continue interacting with your server. That's important when you're doing these multi-client applications for you to be able to rapidly develop. Because if you have a contract between the client and server, you can separate those concerns, and you can actually have two teams working on it. The problem is with tight coupling, even with really great testing, if somebody makes a breaking change and they absolutely need it to be that way on the client side, how do you deal with it on the server side? So this is REST is truly an intermediary between the two, and that's the representational state transfer. Now the other kind of important things are the URI. So every resource has a URI, and we'll get into that a little bit more. So it talks about decoupling the representation of the resource from the URI that identifies the resource, describing the set of constraints. So what can I actually do given I have this blob, and then how do I transfer it? So if I want to add an entity, if I want to remove an entity, if I want to update an attribute, how do I actually do that? That should all be contained within that one blob. So what is a resource then? Resource is, just very simply an object. It has a type, data, relationships to other resources, and methods that operate on it. But the difference between RESTful APIs, so if you've ever seen, some other APIs, you might see APIs that have method names in them. So it's, dog / get dog name, or dog / send to the park. That is kind of anti-RESTful. You want to represent it as a resource, as a noun, as an entity, something that has a type, and your type can be dog, your type can be park, your type can be living place, but you want to avoid making those naming conventions towards the verbs. And the reason for that is, again, because you're dealing with a contract, and you might update the actions that you're going to perform, but that's really on the client side. The server side cares about what is my data, what is my application data, how am I presenting it forward, and then how do we agree that whenever you manipulate that resource, which is sitting in front of the application data, how is that going to impact the underlying data on the computer? So generally, REST methods correspond to the HTTP methods, the get, post, put, patch, delete. So get is getting data, put is updating data, patch is updating a portion of the data, post is creating an entity generally, and then delete is delete. So resources can then be grouped into collections. So collections is just a nomenclature thing. Okay, so this confused me early. I was like, well, what's the difference between a resource and a collection? A collection is a resource. Okay, a collection is just a representation of a group of resources. Typically, you think about that, it's like the index page. It just lists a number of them, and then from there, you can get into the sublinks from there. So looking at this, we can see these are some representations of what that looks like. So you have a singleton resource, which is just one individual resource on its own. You can have resources, you can have a collection that's a resource, and then inside there references multiple resources, or you can have a collection which has resources, which has sub-collections, which has sub-resources, which has et cetera, et cetera. It's a nice little, cyclical, graph structure. So what are the RESTful requirements? Well, we talked about them initially a little bit in this architectural style. So these are the requirements for the style. So first off is a URI. Now, being that this is Web2py and generally most of us have at least dealt with the World Wide Web, we're probably all familiar with URIs, but you have a uniform resource locator. URL, uniform resource indicator. Basically that means that one endpoint corresponds to one resource in this context. Now, in that case, you can think about the World Wide Web as kind of a RESTful API in itself. It's not exactly, but it's very similar because you have those endpoints, and whenever you go there, you have that visual representation that sits on top that has the HTML that visualizes it for you. But from there, that has the links within that you can then go to linked resources. And so when we look back here, we've got hypermedia that were being displayed, and we've got a resource which is an object with relationships. And those relationships, in the case of a website, are just links, right? So if you think about a RESTful API, it's returning you a JSON blob, and it has a whole bunch of links to the children, or links to the pets, or links to whatever else it might be. So RESTful API, URL, that's pretty straightforward. Manipulation of resources through representation. So this really touches on the core of what we just talked about, which is that REST and APIs are really a contract between client and server. So we're agreeing that if I give you a dog object, when I give you a dog object and it has a name of Fido, when I change that name and I send it back to you using the correct HTTP verb, that you are going to do the appropriate thing with that. It doesn't know, it doesn't have any idea what an update name endpoint is. It just knows about dogs. So it's separating it out into little agents, if you will. So every resource is like an agent, and it has its natural actions, and whatever data it gets in, it's going to perform the calculations on the back end in order to give you that representation back. Then lastly, self-descriptive or stateless. So this is important. REST is primarily used, you're not dealing, you don't use the session information in there. You assume that basically the client has that the client is maintaining all of the context for the interaction. So what that means is that REST is very scalable. So you just have to distribute the load, and it has no idea what state the client is in because the client is managing all that. So it's RESTful, and that's another another way to link that into your brain is REST. It doesn't care. It's just kind of chilling back there, and it's going to do whatever it tells you to do, and it's assuming that you're taking care of the deals. Now the last bit is this is why I introduced Hypermedia. So Hypermedia as the engine of application state. Now I put 2 stars by this because there's some disagreement in kind of, in the world about how strictly to implement this. So it can be kind of tedious and tiresome to link references within a JSON object and then have you basically skip it and hit the API again and again and again. So sometimes you have to use some other things. But in general, you want to use your hypermedia, your objects, your resources as the engine to drive your application, as opposed to session management and all that other stuff. So those are the RESTful requirements. So this is what it actually looks like. Now I'll point you to the bottom here. You can see, I don't know if you can see it in the back, but this is, and I'm probably going to butcher the name, but Gert Johnson, or Janssen. So this is RESTful API design.readthedocs.io. So this document was basically his thoughts on how they went about designing the Red Hat virtualization API. So that's where I'm drawing these diagrams from and a lot of the supplementary material. And I highly encourage you, if you want to read a document that will drive the point home, that is where I would go. So what we have here is application on the left, client/program on the right, and API being the contract that binds them. Now there's this little to resource and from resource thing that's in the application interface. Now that's an important note. So your application data model, the data model of the underlying data sitting on your server, doesn't have to be the same as the data model that your resources are presented with. So, and often that's not going to be the case, especially in foreign key relationships. So sometimes in order to manage an object, if you want your resource to be a dog and a dog has multiple tricks, say, and the trick has a name, and then the name has, all of these other things, do you want to make 16 API calls to get that dog resource back? And that's part of modeling, right? So you're going to model the application data model, and you're going to do that in a way that's most efficient for storage. And then you're going to model the API in the way that's most efficient for the contract of interaction between the client and the server. And then this to resource and from resource is basically how do you get back the application's data model, the underlying DB model, from what is going over the wire. And then lastly, sending it to the client. So that's kind of the basics of what is an API, what is a RESTful API, and why do we use it. So let's go very quickly through the RESTful API design thought process, and I realize I'm kind of running just a little bit behind, so I'm going to try and accelerate. So basically, when I come at an initial system and presuming a blue sky mentality, so there's two kind of situations you can find yourself in. One is where you already have an existing application data model, and the other is where you don't. And in both cases, you're still going to want to do the same thing and identify the nouns or the entities that are in your system so that you can know what data do you have to save. What attributes do those, and generally, so this is a general thing, not a one-to-one relationship, but generally the nouns or entities generally correspond to table names. Then attributes generally correspond to fields. And then relationships that those entities have, those are foreign key relationships as well as interactions. So, can I, if I change something, if I change the name over here, does it have to update the last modified field for the dog? What are the relationships that have to be modeled there? And that generally goes into some sort of business process model notation. You don't have to do it entirely formally. It's kind of, it's important over the course of time to kind of formalize those requirements, but that's what I think about. And then what actions or verbs can a client perform on a resource or a collection? And so this is where the transition is going to happen from, direct one-to-one mapping to abstraction. And those actions or verbs are going to be, so let's say you have a disable, or send dog to the park endpoint. Instead, you're going to have a dog location endpoint, and you're going to update that endpoint with the park, right? And so that's how you want to take from, the verb, which is go there, to grouping the verb together in terms of a category of what could you possibly update about that, and making it into a noun. So with that in mind, then I'm just going to take you real quick through, and I think this is the last slide, I'm going to take you real quick through implementation in Web2py and why I love it so much and use it. And I'm going to do that using a recent client that I had by the name of Tony. So Tony came to me and said, I have all these suits, and all of the suits have parts, and I have this really fancy computer, but somehow I just keep ending up, changing the endpoints. And I should say this is not my this is not mine, so I'm not trying to claim copyright over this. This is trademark Iron Man. But so let's just take a real quick look over how would we, if we were to put in an inventory management system for keeping Tony Stark's Iron Man suits up, and running, how would we do that using Web2py? So we'd start out with the entities first out. So we got suits and we've got parts. And so for that, we're going to define our two tables. We've got a suit table and a part table. Then what attributes do we have? Well, suits have a name, a color, a last used, and then suits have parts. So Tony wants to know, do I have to order more titanium or, more plasma cutters for, my special suit? And he's going to keep a barcode because he doesn't want to have to, manually enter it. And he has, his little arm guy that's going to go over there and figure it out and scan it in. So, so from suits, we go to, or from tables, we go into field names. So just pretty much the general way that I do this is go from, camel case and normal case to snake case, because that just seems to be the easiest way. There's no right or wrong, but it tends to work very well for me. And then from there, then what are the actions that we're going to have to take in order to manage the inventory? So we've got creating a suit, deleting a suit, updating a name, updating the color because Tony likes flashy colors and he wants the fire engine red, update last used, adding a part, removing a part. You can create a part, delete a part, update its name, or update its barcode. So basically update any of the entities themselves, add an entity to another entity, or create an entity or delete an entity. So generally, and this is why I love Web2py so much. So this is where it's going to get kind of, I'm going to be jumping back between, Web2py and other things. So what I love about Web2py so much is the routing capabilities. So when I start out with an application initially, I'm going to just create my entities as the controllers themselves. And then the actions I'm going to create as, within the controller. And what that allows me to do is then visualize those actions using Web2py's built-in SQL forms, right? So I can use a grid to get an index of everything. I can use a SQL form and just update some certain actions, and I can process that. And the nice thing is, because of the global context, I can define, as I start figuring things out, I can define global methods. I can take those methods, put them into modules. I can pull the modules out, and I can move them around. I can take controllers and I can pull all the functions out and I can put them into, into one module and just pass in the request object and the database object and the session object. And that allows me to modularize and very quickly and rapidly move between, an initial prototype and something where I can prove out how the flow of data is going to go into something of a production environment. So with that, we'll take a look at a little bit of code here real quick. So we've got, let me just pull this off here. So yes, we really do have Jarvis up here. He wants to help us out. So looking at this, we've got a suits controller and a parts controller. Both of these have, and I'm going to pull up the code here. So we've got a suits controller and a parts controller. So start out with that, and I generally like to leave the indexes up top. Now this is just rapid prototyping, so I like to leave the indexes up top, and that allows me to jump very quickly back and forth to see what's going on with each index, and then I can drill down in and work on one particular functionality and one interaction between any of the two. So start out, and we've got suits and parts. So I typically, when I do this, I define a table at the top, a table variable, and that allows me to very quickly reference it locally within this this one controller. Now you're probably thinking that's terrible. You're polluting the global namespace, this, that, and the other. Absolutely, you're 100% correct. But I'm breaking the rules intentionally, and I'm very well aware of it, and that allows me to move very quickly and say, okay, now I actually, I can copy this entire line, which is just my grid, from one to the other, and all I have to do is change the table name, and I can very quickly move. Now, that means that internally I have to remain a convention that I never use the variable table inside my controller. So absolutely polluting the global namespace, absolutely terrible practice, but I'm trying to talk about what are the advantages here, and the advantages are that because of that global namespace, I can actually take advantage of that and leverage it to move very rapidly. So what I do is I stub in all of these controller actions here, and then because I know the table, all I have to do is start thinking about the queries that I'm going to run, right? How am I actually going to get, you know, a particular suit? Well, I know I'm going to pass in the suit as an argument. And so another thing is, you know, REST typically uses arguments versus variables for some stuff. I know that's a terribly gross generalization. But what I try and do is I try and start mapping my IDs into arguments, and my actions, my sub-actions, my sub-collections into arguments. So here, this is like it's a, you know, a visualization into the RESTful API and into the internals, and then I can actually make it, you know, conformant. Two seconds. So long story short, this is all fine and good. One of the things I love about Web2py is the automatic route generation. So just by, you know, let's say I've modeled that out, and then I'm like, okay, well now I don't want to just use a, you know, just use a website and a web client. Actually using this request RESTful decorator and, you know, auto-generated patterns, what I can actually do is generate a complete RESTful API, and these are all the endpoints that have been generated for me. And that allows me to decouple the logic, and I can work on the database logic while the front-end developer is then hitting this RESTful API and working on it. And, you know, it means that I don't have to maintain that. And as those things get more complicated, I can reduce the patterns and pass them in as a separate function or a separate module, and substitute those in. So that is the RESTful API basics with Tony Stark and Web2py.
So we have actually no time for questions, sorry. Or maybe while you set up the computer, let's have one question. So if you... Yeah, let's answer to a question while he's setting up the computer.
Sorry.
Okay.
Oh, hand. Hello. Questions? No questions.
Usually put the word API I've seen typically in front of the approach. So would you typically stuff the word API in front and then have API? Everybody puts API in front of all the examples.
Yeah, so generally what I do is I assume the nice thing about Web2py's routing capabilities is that you can just think about it in terms of, you know, where do you want it? Do you want your API as an entirely separate application, or do you want it to be like additionally within your application? So usually I start it out as a separate controller, and what that allows me to do is it starts the application as always the first name, and then the second name, the second, you know, argument is going to be API. And then what you saw there is actually just by setting the first action to V1, then I've, you know, automatically set up, you know, versioning in my API. So I can, because my controller will then, you know, my routing is then going to go application controller function. It's going to go application API V1, and then I can do V2, and I can be incrementally doing that with the same code base. And because of the models that have been imported, I will keep all the same data and session management in there. So, alrighty. Thank you very much.
Thank you, Mark.